Okay, the learning objective for section 3 of chapter 12 is to recognize structural or constitutional isomers and functional group isomers. Um, in the last section, I introduced the concept of an alkane. An alkane is a hydrocarbon consisting of carbon and hydrogen only, with the simplest one being that of methane, where you had one carbon and four hydrogens. For alkanes other than methane, each carbon must be bonded to at least one other carbon. That is the carbon-carbon backbone that we were developing. The bonding carbons make up the backbone of the molecule, and for an alkane has a general formula of CnH2n plus 2. So if our number of carbons is 3, then our hydrogens would be 2 times 3, 6, plus 2, or 8. So the formula would be C3H8. Now, as you increase the number of carbons, starting with 4 carbons, you can develop what is called an isomer. An isomer is simply going to be a compound that has the same molecular formula, but different structural formulas. Now, that definition has a couple of other definitions that you need to know. The first is a molecular formula. The molecular formula is what you're used to seeing from the previous chemistry class. It tells you it tells you what element is present and how many of each of those elements are present. So for instance, methane has 1 carbon and 4 hydrogens. Ethane has 2 carbons and 6 hydrogens. Butane has 4 carbons and 10 hydrogens. And then we get into other molecules such as C2H6O, which means it would have 2 carbons, 6 hydrogens, and 1 oxygen. That is the molecular formula. Now, a structural formula or constitutional isomer is going to be a compound that has the exact same molecular formula, but the connections between the atoms are arranged differently. Now, within that, you can get what's called a straight chain alkane. A straight chain alkane is going to occur when you can take a pencil and you can run that pencil through every single carbon within your molecule without ever lifting the lead from the paper. The other type is called a branched chain alkane. And just like a tree, the backbone, the trunk, has branches. And so that's why it's called a branched chain alkane. Now, with respect to your isomers, we've talked about isomers of an alkane, where you can have straight chain alkanes and branched chain alkanes. But we can also have isomers that involve functional groups. So for example, that C2H6O molecular formula that I mentioned previously, that can be arranged in 2 different ways. And depending upon how you arrange it, will determine whether you have an alcohol or whether you have an ether. And so that would be considered a functional group isomer, because it's an isomer of the exact same molecular formula, but because we have arranged the atoms in a different format, we have obtained different functional groups. The second lab that you will be doing is going to be a dry lab. And in that dry lab, we will actually build the isomers of a compound. Specifically, we will be taking an alkane, and we will build the different isomers associated with an alkane.